please briefly summarize your industry education and professional background?
Good afternoon. My name's John Ward. I've been in the coal fly ash business since about 1998. My son used to introduce me as a used coal salesman, but as most folks who work in infrastructure would know, coal fly ash has been used in concrete structures for many decades to improve their quality, and it's getting new ones now. I've been in the industry since 1998. I've been a longtime government relations committee chairman for the American Coal Ash Association, and I'm here today representing Eco-Material Technologies, which some of the folks on this call may recognize from some of its previous names. Boral Resources, Headwaters Resources, or ISG Resources is kind of the genealogy of where Eco-Material came from.
So what is your role at Eco-Material Technologies, and how is the company related to the infrastructure industry?
So coal fly ash has long been a valued input component to the civil engineering and construction industries. Ash, when it's used in concrete, can improve the performance. Concrete made with fly ash is stronger and more durable than concrete made without. Eco-Material has been the national leader. It's really the only ash marketer with a coast-to-coast footprint for supplying that important resource. The industry is in a really interesting state now with coal plants starting to shut down. The availability of that material has seen some regional upsets. And a lot of folks are asking, where is the new material going to come? Where is this material going to come from if the coal plants shut down? Eco-Material actually has a number of initiatives underway to continue supplying the market and actually expand supply to that market by doing a bunch of different things. Harvesting previously disposed ash, utilizing ground bottom ash, utilizing natural pozzolans, which can be dug out of the ground. And most exciting, Eco-Materials on the forefront of using chemically activated ash, for lack of a better term, to create a 100% ordinary Portland cement substitute that would enable even greater concrete decarbonization and use of recovered resources to make high quality concrete with a lower carbon footprint.
Why is cement such an important part of curbing environmental emissions? And why has it been a challenge to make it more environmentally friendly?
Cement and concrete constitute about 8% of the global greenhouse gas emissions. And while early decarbonization efforts have largely focused on the energy production sector, which is the largest emissions, the transition of that energy sector is well along the way, and attention is now turned to other high carbon emitting industries. And when you think about it, to make a ton of Portland cement, you emit a full ton of carbon dioxide. About half of that emission comes from the energy that's used in the Portland cement production process. The other half is just direct release of carbon dioxide from limestone as you calcine it. So, the value proposition then from a decarbonization standpoint is every ton of that ordinary Portland cement that I don't use and can replace with a product like fly ash or Eco-Materials green cement is a ton of CO2 emissions reductions. So it's a significant step toward decarbonizing what is otherwise a pretty hard to decarbonize sector in cement and concrete.
Why has it been so hard to decarbonize?
It's interesting, if you take the long-term view of ash use, coal ash is actually characterized as a pozzolan. We'll geek out here for a minute. Pozzolan comes from the Italian town Pozzuoli, which is on the banks of Mount Vesuvius, and it points out that the Romans over 2,000 years ago were using material like this to make very durable concrete structures for a very long time. I mean, the reason the Pantheon's dome is still standing today, 2,000 years later, is it was made from volcanic ash, which is chemically very similar to the fly ash that we use for power plants today. Unfortunately, we had this thing called the Dark Ages, and some of those construction techniques got lost. And along coming out of that, Portland cement was invented. Now, the advantage to Portland cement over natural pozzolans is not everybody has a volcano in their backyard, but there's limestone everywhere. So Portland cement became the go-to standard for making concrete. But as I mentioned before, it's a very energy intensive and carbon emitting intensive process. And so as as attention has turned toward trying to decarbonize things, one of the biggest issues in trying to decarbonize this sector is just the scale. Concrete is the second most commonly used substance on the earth next to water. And so there's a lot of scale and a lot of work to do to be able to bring this in. But the cement and concrete industry recognizes that some of the low-hanging fruit is utilizing technologies we already know, like fly ash and other supplementary cementitious materials. And then the forefront is products like Eco Materials green cement, which take it from a supplementary cementitious material where you may be replacing 20 to 40% of the cement in a concrete mix to a situation where you can replace 100% of that Portland cement in a concrete mix, still making very good quality concrete.
I just want to say, John, that's a great answer. It's just the kind of details that our readers like.
No, good. I'm glad we'll geek out some more then. How's that?
Sounds good. How would you describe carbon-friendly cement? Is that a generic term, and what fits under that umbrella?
So, a carbon-friendly cement really could be viewed as anything that reduces the carbon emissions from what the baseline is. And the baseline for the past 300 years has been ordinary Portland cement, which is made by heating limestone to very, very hot temperatures and then grinding it and intergrinding it with gypsum to get it to the right reactivity. There are a whole bunch of strategies underway to lower that carbon footprint. One technique, for instance, is instead of making ordinary Portland cement, make Portland limestone cement. Where instead of all of the material being calcined, you've got some ground limestone that's mixed into it. That gets you some incremental gain. You can get incremental gains at the concrete production step as well. Again, using other supplementary cementitious materials like fly ash, ground granulated blast furnace slag, silica fume. There's folks looking at ground glass now. And then, of course, natural pozzolans, which is, the Roman volcano equivalent. All of those strategies play a role, and Eco Material has decades of experience on the fly ash side in terms of managing that material and being able to make it available coast to coast. The real frontier is can you get away from the heating process that goes along with making cement altogether? And that's where a product like Eco Materials green cement, where you're using chemistry chemistry combined with one of the supplementary cementitious materials to create the chemical reactions necessary to make a 100% cement. Using chemistry rather than heat and energy to get that transition. So the quiver has a whole bunch of arrows in it. They're all going to be important, but it's interesting to see how Eco Material has grown up from a company that started as regional mom and pop fly ash suppliers to build a national footprint with strong laboratory and research and development background, and now be able to move into 100% replacement products.
So I believe you answered my next question, but I'm going to ask anyways. What is Eco Material Technologies and possibly other similar companies in the industry doing to make cement more sustainable? And in addition to these efforts, what else would still need to be done to make cement truly sustainable?
A big part of the supplementary cementitious materials world is lining up supply and demand. Oftentimes, these supplementary cementitious materials are made in places that are remote from where the real concrete demand is. And moving forward, companies like Eco Material are deploying a bunch of different strategies that may be appropriate. Different strategies may be appropriate in different parts of the country. For instance, there's more previously disposed coal ash in the eastern part of the country than the west. So there are active projects there where we're harvesting or actually mining that previously disposed ash to be able to supply the markets. In the west, there's more of these natural pozzolans available than you would find in the east. So natural pozzolans are playing a bigger role moving forward out in the West. And then again, finally, there are technology solutions that can be brought to the raw materials wherever they come from, like the green cement product, where we use chemistry to activate the cementitious material, as opposed to waiting for the chemistry that reacts in a Portland cement mix.
So what do engineers need to know about carbon-friendly cement so they can foster its use and improve their designs, systems, and structures?
So specifiers are seeing about three different things going on right now. One thing that's very important is we are seeing continuing activity in the standard setting bodies, like ASTM, where the consensus standards for the use of these materials are being revised to be less prescriptive and more performance based. So, for instance, in ASTM C618, which is the specification for fly ash and supplementary cementitious materials in concrete, there have been a number of revisions lately to allow for harvested ash, ground bottom ash, some of these other strategies that are allowing us to plug the hole that's created when coal plants shut down. That's an important thing. Another thing that's going on is the government, with the Inflation Reduction Act last year, is going to be pouring a lot of money and interest into incentivizing lower carbon building materials. And these materials have a role to play there as well. So specifiers, if they're doing work with the federal government, which you are if you're doing infrastructure, are going to be relying more and more on environmental product declarations and some of those things. And the ash industry is actively involved in developing those materials to assist specifiers. And then finally, I would point out that if all you read is the headlines that say coal is going away, and you're a user of fly ash in the past, you might get worried about where am I going to get this stuff moving forward. And I would just assure everyone that there's still going to be an ample supply of these materials as we get the logistics worked out. We are still disposing of almost 40 million tons of fly ash every year in this country, and so we can do things to get that. There have been the estimates of how much fly ash was previously disposed range between 2 and 4 billion tons. That's billion with a B. And we now have technologies to go out and harvest that material, dig it up, put that into progress. And then, of course, the new technologies that are entering the market, like green cement, which provide even more decarbonization bang for the buck than the traditionally supplementary cementitious materials approach.
So if you could provide just one piece of advice to engineers looking to improve their sustainability through cement and other options, what would that be?
The one thing that I would point out for anybody who works in concrete infrastructure, you're aware already about the performance improvements that come with using these materials. Lower permeability, higher durability. The American Road and Transportation Builders Association a few years ago did a study that showed ash used in concrete saves over $5.5 billion a year on federal road and bridge construction, just because that concrete lasts longer. And so my one piece of advice is, as the world starts moving toward, great new ideas and the need to decarbonize concrete, you've got a proven strategy that's already out there. And the stars are aligning to keep that material available. So, keep fly ash in your specifications, keep looking for the new applications that are coming to the market that actually will enable you to use more of that material to create even greater decarbonization benefits. When you use fly ash or green cement in concrete production, it actually has both mechanical and chemical benefits that cause that concrete to be more durable. On a mechanical level, fly ash particles are smaller and spherical. They're like little ball bearings. When you compare that to a Portland cement particle on a microscopic level, the cement is bigger and more jagged. So that when you add fly ash to that mix, it physically fills in the gaps, and the fact that they're hard little glassy spheres gives them a roller effect. So you can use less water in that concrete mix. Less water in the concrete mix going in means less water bleeding out, means less cracks, micro cracks form in that concrete that allow water back in to deteriorate it later on. The second thing that happens when you use these materials in concrete is a chemical reaction. If I make concrete just using ordinary Portland cement, when I get that cement wet, it hydrates, it throws off a lot of heat, and it makes two things. It makes calcium silicate hydrate, which is the durable binder that holds the concrete together, but it also makes calcium hydroxide, which is lime, which does nothing for the concrete. And so for every 100 pounds of cement I put in there, I make 34 pounds of lime that's not doing anything for me. Now, when I add a supplementary cementitious material like fly ash to that mix, it reacts with the lime that was created by the Portland cement hybridization process and makes more of that durable binder, the glue that holds the concrete together. So not only do you have a physically tighter concrete mix, you also have more of the durable binder in that concrete matrix. So it makes for much lower permeability and a much more durable concrete moving forward.